All right, so thanks again for joining. Today we'll be reviewing Creo 7, which is now available. It's been available since April 14th. There's some new functionality, some of which is native to Creo 7, some of it are additional extensions. So we'll be looking at that. We'll be giving that quick intro, show you what is there, and then of course, if there are any questions, we'll happily show you that. If you have a subscription with PTC for Creo, then you already have access to Creo 7. There's nothing that you need to purchase. So what you see today is available. You can just go and download it. If you have any questions or need any help with that, please feel free to reach out to me. You can see my contact information down here at the bottom. I will also, of course, send out the recording link in a summary, so you can just respond to that if you do need any help there. So just a quick reminder about who is Elite. We are a PTC partner. We have a couple of factories of our own that we produce parts for the aerospace sector primarily. A couple things outside of aerospace as well. But we do manufacture things and we use the PTC tools ourselves. That's what led us to become a partner. And we use Windchill and Creo, and we do design projects. We manage that in our own database and then produce those in our factory. So we use as well as support all of the tools and provide all these services along with them. So of course, if you have any interest in any of those, please feel free to reach out to me. But with no further ado, I would like to introduce Paul Dye, who is joining us from PTC at the Virtual Center of Excellence, and he'll be giving us our intro or sneak peek into Creo 7 today.
All right, thank you very much, Stuart. And can you hear me okay right now, Stuart?
Yes, I can.
Awesome. And so, again, for everybody, my name is Paul Dye. I am an application engineer out of PTC, specifically out of our Virtual Center of Excellence, and I primarily work around everything Creo. And so that's really what we're here today to talk about, is exactly what we have new here in Creo 7.0. And so obviously here, there's going to be a lot that's going to pertain to probably what you do in your design work, maybe some stuff that doesn't necessarily pertain to what you do currently, but a lot of interesting things and maybe some interesting new directions to move into. And so with this release of Creo 7, obviously there's more than we could cover in just 30 minutes or even an hour. So to focus more in on some of the main ones, we're going to start here in the first section, and that is around core modeling features. So first, we have improvements to the import data doctor. If you're going to be bringing in non-native geometry, we now have support for MultiBody. And that's something that we're going to get into talking a bit with that MultiBody design. And around specifically with the import data doctor, there's now a troubleshooter looking for things like open quilts and how we get through and fix those. And next, we have new display filters for geometry representations. So when you're showing these different representations, we've improved your ability to show off the different features. So for example, here, if you wanted to highlight on those lattices, very clearly show those off, have the rest be a little bit more transparent, and other options around that. We've also made enhancements to the draft feature, specifically like things around drafting already drafted features. And we also have the ability to detect existing draft angles right in the model, so it makes it very easy to work with and modify later on if you need to. Also improvements around the performance of the snapping to geometry or grid. We now have more control over that. So now in the quick menu, you can very easily switch that on or off, kind of depending on what you're working on. So for a little bit, you might want to have it on where you're snapping to a predefined grid or predefined features in the model. And then as you're doing maybe some other work that doesn't necessarily need that, you can switch it off and simply work in whatever way you want to. Made enhancements to the mirror tool in the sketcher. So made it very easy to grab things and mirror. So now we can essentially just grab on any straight sketch and use that to mirror about. And we can move that sketch around, and our mirror feature is going to update for wherever we move that around to. We made improvements to the visualization of the design intent in the sketcher. So really improve the look of the relation icons, able to highlight references, change colors, overall modernizing the look and the feel for working in that sketcher and make it easy to work around. And in the edit dimension selection, you're able to set the appearance of your sketcher constraints. So when you click to edit those dimensions, also show the constraints. So that's another config option that you can activate there. So really, that's just a quick look over some of the general improvements that we've made to core modeling. So now we can get more into some of the applications. So starting here with Creo Simulation Live, aka CSL. So if you haven't seen or worked with this before, this is a tool that we've developed as part of our partnership with ANSYS, and that's to put real-time simulation right within the modeling environment. Around this improvements, first thing here is we've added the ability to control the direction vector from a selection. So we don't have to have that set by a default. You can simply select on features and really work off of that and have that be the direction, and it builds out the XYZ for you. And building off of that, you're not locked to working with the global coordinate system. You can now select any coordinate system to define those load cases from. So improving the general ability to define those loads right around the start of the study and whatever type of load cases that you need to build out for your part of your model. Also made enhancements to the legends, so this is something that's very easy to work with, has a lot of capability, specifying what you want to look at, how those values are displayed, and essentially setting the upper and lower bounds for the values that you're displaying. So it works very well with those composite views where you're only displaying views or values within a certain range on that legend. We can also use values that we get from our simulation probes over in our behavior modeling studies. And what behavior modeling allows us to do is to take values like, say, max von Mises stress, displacement in a certain area, and we can start to optimize around it, where we tell the system certain dimensions that it can change, and the system goes through and automatically optimizes the model for you, more of a parameter-based study. So based on what you allowed it to change, it's another very useful way of actually using those analysis results. We've also added more real-world simulation constraint types, things like ball, pin, planar constraints, helping to make each of those cases more realistic to the actual problem or the situation that you're really trying to design around. CSL also has now support for multi-body design, and again, we're going to go to a little bit more of that after this, but there's a ton of different applications for that, like cavities, internal, external, volumes, domains, and much more around those. So that's something that we'll be able to utilize in CSL. And at the end of this, I'm going to go through a demonstration working in another type of study, specifically around flow analysis. But here also is one of the big improvements here in thermal studies. We can now do transient studies, aka time-dependent analysis. So either do it at steady state, or we can see here, it allows us to see how our results are changing over the course of time or at a particular point in time. So either now do that steady state or the time-dependent as it relates to the thermal studies. Again, probably the biggest change to CSL is now the option to do flow analysis in the same way that we do for structural, thermal, and modal, where essentially what we're doing is we're starting off by creating a fluid domain. We specify which areas to include or exclude, define the inlets, outlets, specify maybe the materials that you're going to work with in those fluid domains, and from there, visualize it right on top of the model that you're working with. And that's the idea with this, is regardless of whether it's an internal or an external case, be able to visualize it right in the model environment. Along with that, a lot of different options for the results that we're getting. Visualize the streamlines, the particles, taking section views, direction fields, setting probes. It's really a powerful and also very easy to use tool for doing that type of flow analysis. Where normally, if you wanted to do anything around flow analysis, it's just not valuable typically out in the industry for most anyone to work with. But now what we're really doing is taking these tools and, like we've done with other parts of CSL, putting these flow analysis capabilities in the hands of our designers and our engineers. So it's not something that we have to send out to an expert analyst, something that we can do right within the design environment. We'll talk a little bit more into that later. I do have a brief demonstration we'll see with the CSL flow analysis, but the next big enhancements that we're going to cover here is mainly around the multi-body design. What this offers is really a new way to design in Creo. This type of multi-body design methodology really allows you to be flexible in the way that you design your parts in the model, so where each of those bodies can be handled differently. You can have different materials included or excluded from your mass calculations, how you define your global interferences or clearances. There's really a lot of different options around this. It's something that's going to be supported mostly everywhere in Creo going forward. So these bodies that you create are an entirely new object type within Creo, and they appear right in the model tree under bodies. Each of those bodies can have their own individual appearances, parameters, attributes, and again, with each of those, have different operators for working within that geometry. So you could go through, merge bodies, subtract, define how they're intersecting, and once you've done what you need to do, you can make part files off of any of those bodies. This is something that's really powerful and really kind of a separate way to work here. So if you've never worked with MultiBody Design before, it's definitely something that you're going to want to try out. So for some people, the standard way that we're used to working in Creo is going to work just fine. It's still a great way to work with things like skeletons, published geometry, that sort of design methodology. But for many people, this type of Boolean work where you're merging and subtracting bodies is going to open up a new world of possibilities. So doing multi-body design is getting you there much faster and easier for some geometry as opposed to, say, your typical surfacing and quilt-based workflow. It's really just dependent on the types of geometry that you want to build out. We can go through and do that. So there's really a lot around that, and a lot that I really can't focus on today because it requires a lot to go through and explain that methodology. So obviously, if there's ever a need to go any deeper into that, we can set that up, Stuart, and maybe take a deeper dive into what we work with around multi-body design. So that's something that really activates and gives us a lot of other capabilities within Creo. And here's one of the biggest developments we have in the release of Creo 7, something you may have seen around, is the introduction of generative topology optimization. So this generative design, it's autonomously creating optimal designs from a set of design requirements that you specify while going into the study. So when you get into Creo and within the generative topology optimization, you're going to be able to specify requirements and goals, and the generative design is going to automatically produce a manufacturable design either as a starting point or as a final solution. So it allows you to try different materials, physics, manufacturing constraints, and automatically create that geometry. This allows you to try out many different generative design studies to kind of explore all different types of design alternatives and compare the results between each of those to start working towards the most optimal design. So with this, you're able to visualize real time all that generation, even when you're modifying or changing your input geometry or making changes to the design criteria, have that update and see those changes. With that process, it really allows you to interrogate and review the analysis results. So see what your stress values are, what's the deformation, and as you're starting to get those results, go back through and change things. Change around the design constraints, any of the geometry, try different materials, and see what that does to the model and the geometry that you're getting out of this. And we're really able to do this because it's all integrated right in Creo. We've integrated this frustum technology right into the modeling environment. It's not some separate window or software you have to switch over to. All we do is define the geometry, say what we can change, say what things we can't change, what things that we want to be fixed in place, any constraints, and then just let the system go. And once that system generates that design, you've had the chance to kind of review it, go ahead and update the results to use elsewhere in Creo for any kind of further refinement and optimization. So to do that, we're able to take the design and actually convert it into solid B-rep geometry. So in that process, we have different options for how the model is reconstructed, and we can go back and forth between the two, kind of see what's changed and really do that to get the best model possible, all while still having pure manufacturable geometry. And this is useful if you have things like metal 3D printers, you're going through and creating that geometry, or even if you just wanted to use these design or generative topology optimizations as a reference. Go through and see what it gives out for you, see the geometry it creates, and then go back and just kind of parametrically build out those features and use that as a reference and something to design around. Change the goals and still see how the generative design builds out that different geometry. Moving on now, we've had some improvements over in the world of additive manufacturing and 3D printing as well. The first thing here is with the creation of stochastic lattices. We've enhanced the way that this type of lattice follows along some of the hard edges that we have in some of our parts, makes those structures even more structurally sound. So that's using a different solver type that we have an option for now with those stochastic lattices. We also have improvements of custom lattice cells. So if this is something that you haven't worked around, this is where we're taking a part file and actually using that as the cell to create the lattice from. So in the past, we've had the option for full geometry, but one thing that we've included now is actually an option for a more simplified B-rep geometry. So it's especially useful if you're creating, say, hundreds of thousands of these cells, be able to create it as more of a simplified B-rep and have that propagate much more easily. Specific here with the Additive Manufacturing Plus extension, we've made improvements to the tray assembly definition using that multi-body design methodology. So even with the same part file, have those different bodies with different parameters, wall thickness, colors. It's really a lot of uses to doing that there. And then on the other side of things, we've also made improvements over in the machining world. So first here, we can now view synchronized tool paths in the graphics area. We've always been able to synchronize those tool paths, but now there's a synchronization menu where you can highlight on what you want to see, go right there in that menu and view them and keep track of everything. It makes it very clear to see what you're doing there. And also have multiple go home positions where, again, we've always had the go home command, but now some machines that you're working with now need multiple go home positions. So especially if you're doing things like mill turn operations, have home 1, home 2, home 3, however many you need there for those go home positions. And finally, the ability to explicitly call out Swiss turning operations. If you have a mill turn machine, you can say fix the Z-axis and put all the appropriate cout commands into that output file. And that's something that's going to work very well with the Swiss turning as part of our complete machining suite of tools. Now moving on here, we've made a lot of changes to continuing to support the work we do with detailing and model-based definition. So really a lot of work done around this and something that going forward, we're really looking at something to work with a lot around in Creo and just the way that we build out these designs and also start to go through and manufacture on these and the way that we actually build out these definitions based around the model. So first, of course, we've included the multi-body support in our drawings. So if you have different bodies with different materials, even if they're right within the same part, you can make those different cross-hatchings to differentiate them. So really supporting the work we do with that multi-body design. We have then repeat regions in the drawing for multi-body parts, exclude certain bodies, include that all right in your tables, however you want to define those there. And then over in the drawing model tree, have control over those different bodies. Identify bodies, hide them, and keep it all straight throughout that. Next, we can configure drawing view tooltips. So if you click on that view, you can see what the part is, the model, combination, or explode state. With that as well, we have a new summary view command where we can click on an element and have the system kind of tell me all about it. It's a good way to understand the design intent. And it's especially useful if you weren't the one that created the model itself, still go through and get that information that helps you going forward. Improvements around the addition of drawing tree columns, so adding those in now is an option. And even around that, be able to sort the drawing tree by view models and parent views, building out that drawing tree however you like. Next, improvements to removing hidden lines. So this is something that you've worked around. If you wanted to, if you have a view that you want to remove some of those lines from, this is now very easy to do. And we've supported a lot of the way that you want to go through and build this out. We can have the, now we can move the arrow with the name. So you can have a link between the two. Whenever you move the name around, the arrow is going to follow. So it's not going to be two disjointed things unless you want it to be. You can kind of turn that on or off. And now we also have the ability to add multiple leads. There's an option where you can have multiple normal tangent leaders all coming off of one common annotation. So it's really helpful for GTOLs, notes, symbols, anything around that. Next, we're able to align ordinate dimensions with a baseline. So this is something that you'll run into if you're working with the ANSYS standard. It's how they like to do it. So we've built out those ordinate dimensions to work well with that baseline. We can control the length of the intersected contours. So beyond the intersection point, you can enable those intersection witness lines. And we have child view identification. So very easy to see where drawings go to, especially useful if you're going to be working with multi-page drawings or even if, again, you weren't the one that created the drawing, that can be very helpful for keeping all of that straight. Continuing to make improvements around GTOLs, so now we have additional indicator values, things like intersection or collection plane for angularity, in this case for the ISO standard, if that's what you work within. Also have some options for controlling the gap between the GTOL and the indicator frames, depending on the standard that you're working with. So depending if you're using ISO 11101, 2012, or 2017, any of those ones that you work with, you're going to have different options for that potential gap size. That's something important there. Around those standards, as they keep getting released, Creo is going to keep evolving right along with them. So now we've included support for that 1101 2017 and also ASME Y 14.5 2018. Finally, in here, we have some options around the alignment of spacing when it comes to composite GTOLs. So depending on how you want to define those GTOLs or how you want them to align, on the left, on the right, it's all done kind of keeping track and keeping up with those standards. We added some new symbols in the symbol palette, particularly the angularity symbol for an intersection plane, runout symbol for a direction plane, and we also have a symmetry symbol for a collection plane. So if you work with any of those, that's a nice added feature there. And we've updated the parser for the syntax checker. Again, taking into account those new standards, making sure it all works. So this is really a lot of work that we've done to keep up with the world of detailing in MBD, and something to definitely keep track of and kind of look into if that's not something that you currently do. It's definitely a great way to kind of work with these types of designs and how we define them. Render Studio also has a few new options included there as well. So first thing here is the ability to pause and resume during the rendering, where normally if you're in this mode, it's constantly running by default. But if you know that you're going to be needing to make a few changes, you can simply just pause that render and give the computer a break as you go through and do that. You can also now render the mannequin vision window. So this is something that we're essentially taking the view of what the mannequin can see, that person, and what their eyesight is on the model. We can actually render that view to get some really nice shots around the model. We also have now the option to define a custom floor plane for the render. Allows you to flip the model, change where the shadows and the reflections are going to appear. So now you have that added level of customization with it. Also had improvements in the world of augmented reality in Creo. So this is something that we've actually been building out for a while now, where we're able to view these models as AR experiences. So this is something that now we've actually included the ability to publish combined states as part of the experience. That combined state can include exploded views, sections, different appearances. All of that can be included now with it. With each of those different states, the user can switch between each of those. So very quickly and easily switch from one view to the next. And if you have these different view options, that's something that you have now when you're actually publishing over to our Vuforia View. And Vuforia View is our free to download, free to use application for actually pulling up and viewing these augmented reality experiences. So this is something that's really cool and very useful if you have a design you want to share out with somebody, but you don't want to send over that whole PRT or assembly file. You can just simply send it over. They can pull it up using Vuforia View, even if it's someone not in your company. You can just have them pull up the experience and see what that design looks like right on the table. So very interactive and very cool way to do things like design reviews or just kind of showing off the things that you're working on. And finally in here, I'd also like to discuss some of the improvements to the Easy Tolerance Analysis tool in Creo, formerly known as the Tolerance Analysis extension. Same thing now. So if you haven't worked with this tool before, this is a one-dimensional tolerance stack-up analysis tool powered by one of our partners, Sigmetrics, to perform these tolerance analysis in our Creo assemblies. So this is something that right from the Creo design, works right from our annotations and our dimensions. It takes those tolerances, GD&T information, and as we go through and make changes, have all those changes propagated to update the analysis data. With this change, we've done a lot to update the look and the feel of the tool, made the user interface easier and kind of faster to make these dimensional stack-ups. With those, you can define multiple stack-up analysis per model, and we can evaluate many of the impacts from those studies to look into things like statistical results, defects, worst-case scenarios, RSS. It's really useful if you're doing things like Six Sigma evaluation. You want to make sure that we're not getting, over 50,000 defects per million parts that we create. Something that the easy tolerance analysis is going to be your first step, working on Creo, building out those designs, and really getting out the best possible parts, even taking into account things like manufacturing errors, because that's something that you're just not going to be able to avoid a lot of the time. It's your tool for kind of working around this. So that goes over most of the general enhancements or some of the things that we like to talk about there. Obviously, there is a lot more than we could really just go through and talk about there, and things that if you wanted to get any more information on, obviously we do have a lot of that, things like release notes, that kind of thing. But just really to show you, again, what the new user interface kind of looks like. If you haven't seen what we're really working with here moving forward with some of the last releases of Creo, I'm going to go through and show a little bit more into how we work with something like a Creo Simulation Live flow analysis example here. So I'm actually going to demonstrate what that process of working with one of these analyses or studies looks like. I need to pull that up here now. All right. And so for our demonstration here of the flow analysis, we're going to be working in Creo Simulation Live. And the model that we're going to be working with here is actually a muffler off of a motorcycle assembly. So this part actually came off of one of our customers, Royal Enfield. So it's the muffler off of one of their data sets. So we'd like to simulate some of the flow that's happening within that system. So we can first start by taking a section view to see what we're working with here to start. There's definitely a lot of great geometry within here that we're going to be able to utilize and to begin to kind of change around as we go further. And so to start into this, we simply just go right up into the top into our live simulation, click to see the different types of simulations we could add. So with CSL, we have structural, thermal, vibrations. In my case, I want to work with a fluid simulation study. And the first thing we lay out with that is the fluid domain. This is the volume of space that our fluid flow is going to be contained within. To do that, we'll start by defining the inlets, where the flow is going to be starting from. Next, we'll define the outlets. What the system does here is it automatically builds out the internal volume for that model. So something that we can review, accept, and now it appears down in the model tree. It's something that I can go back, make changes to later on. From there, I can define the fluid material that I'd like to analyze. In my case, carbon dioxide is going to be a very good approximation of what's going to be coming out of my motor into this muffler. And we have a few basic materials laid out there in that's going to cover, 95 to 99% of cases that you're going to get in when working with a flow analysis. So next, I'll go through and see that we have that carbon dioxide, and we'll go through and also set up the fluid flow velocity for my muffler. Essentially, how fast is this going to be coming in from my motor? To specify the surface I want to work with, also set the direction and the magnitude here for my options. And we're good to go. And now that I have that flow velocity set up, I can also set up other things like our thermal conditions, such as prescribed temperature at the inlet. So I can set that value, set the units that it's going to be defined by, and whatever regular operating temperature is going to happen around that motorcycle exhaust. So now that we've had that defined, I'm pretty happy with the initial conditions I have around that inlet. So the next thing I want to define is an outlet pressure for my muffler. So moving around here to the back end, and for my case, I'll simply just set that to 0, essentially just outside air. With that, I'm pretty much ready to jump into the study. We also have some quick options here for the actual simulation quality when we run. And so we could slide this all the way over to the left for the highest speed, keep it all the way over to the right for the highest accuracy, or maybe somewhere in between. In my case, I want it to be at the highest accuracy. And with that, we simply go ahead and click to simulate. You can see essentially, as soon as I click to run that simulation, we're getting results back. It really is that fast. I have the ability to go through, change things over my legend. Maybe if I only want to see the velocity within a particular range. Also have different display options that I can choose from to visualize the flow. So seeing individual particles, how they move, and with that, even more options for the particle to change the size, transparency, really getting this into the way that I want to look at it. Helps me to understand exactly how that flow is working and how it works depending on how I set my model up. The particles are a really good way to analyze the flow. We also can look at a direction field. So this direction field acts as a cut plane that I can use to see the direction everything is going. I can move that cut plane around to different parts of the model. So first here I can pull up the dragger tool and change that around and kind of see the direction I want to move it around from, see how that is moving based on how I define my model. Helps me interrogate certain areas, even if I want to type in specific values for that section, go through and see at very particular points in the model. As we can see, there's a lot of different ways to visualize those results, but also we want to be able to analyze and begin to build off of that. Starting here with a simulation live probe, this allows me to see different values in the model, such as the max velocity that we're getting at our outlet, and see how that changes with our flow. Along that, we can see something like our graph here with that probe to see how those values are changing. It helps me to see what's happening at that outlet. So we have other options for viewing pressure, temperature, vortices. So now these are all things that we can begin to actually design around. And one of the ways that we really use and design around is with the design exploration extension within Creo. So what this is our tool within Creo for trying out new designs, iterations, branches off of existing designs. And instead of how we would normally do it by making lots of copies and doing save as all the time, we work right within this one exploration session where we start into it with the pre-modified version of the model. And as we go through and make changes, instead of saving copies, we just make checkpoints at any place that we might want to come back to or branch off of. In this case here, we have these internal baffles, these tubes. Well, what would happen if I wanted to make them a couple inches longer? So even though we're in this design exploration session, have the flow analysis running, we're still able to do this standard sort of CAD Creo work that we're used to. The difference is now, as soon as I make those changes, see and get that instant insight into what that does to our analysis. So I can go back, I can see things like the particle flow, we can see, what that's doing to our velocity, see if it's increasing or decreasing, and it's especially important down by that outlet, so kind of see what's happening there. So that's not something that I send off and kind of hope to get results back by the end of the week. I make the change, I see the result. And if I'm happy with the change I made, again, make a checkpoint showing that I increased the length of the pipes there. So we can see that, DEX or Design Exploration Extension is keeping track of all those changes that I'm making. What that allows me to do is keep making changes to my design. So maybe in a past design, I built these pipes with holes in them. Now I want to see how this design would work if I activated those holes. So I'll activate that from the model tree. And immediately as we go through and do that, we can start to see we're getting a very different type of flow down by our outlet. So we can check the probe, check the graph associated with it, and clearly see that we've started to increase that outlet velocity, but we're able to check out other values as well. Switching back over to that composite view, see how the velocity is moving through those pipes, check the pressure. Seems like we really kind of started to smooth out that pressure flow throughout the model. That might be really useful in order to see exactly where the max values are in the model, to kind of have those move to the front of the view here. And similar to how we did with the direction field, we can also go through and take a closer look into how the flow is moving through those holes we added into the design. So let's switch back over to the back, see what that's doing there. It's kind of moving through those baffles and kind of almost reversing the direction. We can see that very clearly here with that direction field. All right, and so I'm pretty happy with the changes I made so far. And to capture that design intent, I'll make a checkpoint, show right where I was whenever I made those changes for the holes. So that's something now that I can check back on, switch between different checkpoints, and really start to capture the work that I've done throughout this design. Now I'm pretty happy with where I'm at more towards the outlet. So let's move and kind of direct our attention more towards the beginning of that flow. So right now we basically have a solid cylinder with a bunch of pipes going through it, but I want to make a change to that design. So first what we'll do is we'll clear out that feature that I have right now and instead start with more of a clean slate that I can begin to add to. We're also going to do here and use one of our multi-body commands to very quickly remove that body from the model. So select that, activate, and with that area now cleared out, we can begin to build out some new geometry there. And what I want to actually add in here is a lattice feature that we can have to regulate the flow through that channel. This could be something that we're going to create using additive manufacturing. And to start, there's really a lot of options. So we'll first begin by specifying the surfaces or the area that we're going to use to define where that lattice should be placed within. So this is what we call a lattice region. We'll simply go through, select any of the edges or the surfaces that we want to define that region. So latticing is really a feature that we've had a lot of focus on over the past couple of releases of Creo, and really gives us the ability to create some robust, complex structures that can have a lot of different uses, especially in the world of 3D printing here. So quickly define our coordinate system, say where that cell should be located, and then define what that cell shape will be. We can do lots of different 3D shapes, or kind of like what we're doing here with more of a 2.5D shape of change it to a hexagon, change it to a square. And this one's a bit big, so we'll size it down. Once we have that picked out, we can change some other parameters around it if we'd like to. So this is starting to look a little bit thin, so let's change up that wall thickness, increase it by a bit. Here, let's visualize what that's going to look like here. And if I like that view, we can simply accept those changes. Again, even though I made a fairly significant change there, the analysis, it's already been updated. You can go through and analyze the effects there. So change the display state, change the result type, see how my pressure changed around those lattices. And we can check back around the velocity at the outlet of my muffler. Kind of see we're starting to get a lot of changes here, and it's very clear to understand looking at these different visualizations, go through and kind of see all the values associated with it. And so once I've had the chance to kind of look over these, check with that probe, check with the graph, see how those values are changing, this is something that, again, I can make a checkpoint around or simply accept those changes if I'd like to. So here we've added in that lattice. This is something that now, if I'm happy with the design set, I can choose to accept the changes and move that back in and be applied to the parametric model. So the design exploration is a great tool to work with, but I don't even have to be in design exploration extension to make the changes to my model, right? This could be a day or two later. Someone on my team says that we need to, hey, Paul, we need to decrease the outlet velocity. Well, to decrease the outlet velocity, a good place to start might be around that outlet diameter. Probably want to increase that a little bit. So once I make that change, simply regenerate the model, and my analysis updates right along with it. So I can check out that probe, see the values that I'm getting for the velocity. I see they're actually starting to drop off now. Seem to be getting maybe around 240, 250 meters per second. So that's really the idea of working with flow analysis in CSL. Make the changes you want, try this, try that, try anything. We don't want to have to limit the amount of creativity that we can have in our design by waiting around for results to come back from the analyst. Something that I build out the model the way I want and immediately get that insight back into the process. So that's our general overview of talking and really going over what's new in Creo 7. So obviously a lot of different things that I can't necessarily hit on everything to really hit on what we might be working on there, but those are a lot of the main things that we really see as important for a lot of different customers there. And so I can pass it back over to Stuart now. And obviously, if there's anything that or any questions you have, you try to answer them here, or there's a lot of new material. So if there's anything that I don't know, obviously I can reach out and get that information for you.
Thank you very much, Paul. If anyone has any questions, you can put them in the chat session. You could also unmute yourself and go ahead and ask them. While we wait to see if there are any questions, just a couple quick clarifications. There was a bit of a mix in the things that you saw for Creo 7 as far as what's updates versus new extensions. So most of the features that you saw related to Simulation Live, those are all an additional extension, either CSL or CSL Plus. But then some of the functionality, such as MultiBodies is included. That's not an additional extension. That's part of Creo once you start using 7.0. So it's a little bit of a mix. If there's any questions about that, please let me know. I'll be happy to clarify. I'm not seeing any questions coming in just yet. We'll give everyone just another moment in case there are, but if not, thank you everyone for joining. Paul, especially, thank you for joining and giving the presentation. I have personally gone through and downloaded Creo 7, and I'm actually, after this, just gonna get it installed and start using it myself. So I look forward to trying out some of the updates. And one last thought that I will leave you. Creo 7 is what PTC considers an extended support release. So Creo 4 was the last one, which means that every 3 releases, they have much longer support. So you can expect that this is a release that will be supported longer. So actually Creo 8, which will come out a year from now, will fall off of support before Creo 7 does. And they make these major releases, the ones that they recommend that you kind of move to, and then the rest are a little bit more incremental. So if you're only going to update every couple years, that's the cycle you want to get on. I would recommend updating to 7 And then the next major release should be Creo 10 as well, every third year. So they put a lot of extra work, testing and functionality into them, making sure that they are extra stable and extra worthwhile, because those are the ones that they recommend. All right, so I don't see any other questions. So I guess at this point, thank you everyone for joining. And please, again, let us know if you have any questions or anything we can help you with. Hope you enjoy the new version of Creo 7.